in this video. Hello everybody and welcome to the 71st video on my channel. Today it is another advanced trigonometry / advanced geometry video, and it is another example video. So that's about all I have to say. Please make sure to like, subscribe, and hit that notification button for more awesome videos just like this. And without further ado, let's move on to the lesson. For today, we only have, of course, one example, but this example is actually slightly more complicated. And there's a few things I need to cover when we're going in between the solving the steps. So let's start solving this example. Now, if you look at this, there doesn't really seem to be much going for it. It's very confusing and there doesn't look to be that many properties. There doesn't look to be that many properties when you look at it immediately, and it's not glaringly obvious. Now, many proofs will look like there is no problem to get from beginning to end and prove it, and sometimes you will need to use trial and error, which is going to be showing a lot throughout this problem. There are ways to make it slightly better and tips to watch out for, but sometimes there is also trial and error, and that's really necessary knowing how to do that when you're using proofs. So let's move on to directly solving. First tip I have is always look to factor. Whenever you factor things start to get simpler, and you might notice properties slightly easier than if you don't factor. So the first thing that we're going to do is we're going to factor sine x from the entire equation. As you see, we have sine cubed x and sine x. So if we factor out sine x from the equation, we get 3 cosine squared x minus sine squared x. Now, it looks a little better, but there still doesn't seem to be much. Now, this is where pattern recognition and trial and error will come. What you need to do is look for anything that might even resemble a property. For example, there might resemble something like sine alpha plus beta, or they might resemble something like the law of sines or the law of cosines with a little careful manipulation. You should definitely pause the video and look for any solutions or any theory or any formulas or identities if you see them. Now, I assumed you paused the videos and looked, and we'll go over how did it go. So, what property you could have noticed was if you saw cosine squared x and minus sine squared x, you'd have known that's the equation for cosine of 2x. Now, the equation for cosine of 2x, and the equation for cosine of 2x is just cosine squared x minus sine squared x, but we have 3 cosine squared x. So, the next step that we need to take is do sine of x, of course, factor that out. Then, what we have is 2 cosine squared x minus plus cosine squared x minus sine squared x, and then we have that all in brackets. So cosine squared x minus sine squared x is cosine of 2x. So we have sine of x, 2 cosine squared x plus cosine 2x. Now we want to do trial and error again with the different properties. And if you don't really notice much, and if you do notice properties like in this, you have this is equal to 2 times 1 minus sine squared theta by an inversion, I like to call it, of the Pythagorean theorem. But if you continue on and you solve it and it doesn't look like it, that is going to be the solution, go back and try again. Now, in this, we're going to actually distribute across the entire equation. What we have is we have sine of x times 2 cosine squared x, sine of x times cosine of 2x. What you want to do here is you want to look for any properties again. And you always want to do this on every step of the way if you're not directly simplifying from a property. So, if you look here, we have sine x and cosine x multiplied by each other, and as an added bonus, we also have 2. And 2 sine of x cosine of x is equal to sine of 2x. So if you look at it, the only thing that's standing in our way is cosine squared x. But what we can do is we can do 2 cosine x times sine x times cosine of x plus sine x times cosine 2x. So this becomes sine 2 of x times cosine x plus sine of x cosine of 2x. Now, if there's no more simplification, we want to look for another property. Now, as always, please make sure to pause the video because it's really going to help if you try and recognize this. Now, I assume you paused the video, and the property is shown here. As you see, you have sine and cosine with the same 2x, and cosine and sine also with the same x, and they're kind of interchangeable. So, if you notice the pattern, this is actually sine of alpha plus beta. Now, when we have sine alpha plus beta, it's quite important actually to simplify that because, of course, it's a property. So, what we have of sine alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. What we have is if we have alpha as 2x and beta as x, it's going to be a pretty easy to solve equation. So we have sine 2x plus x, which becomes sine of 3x. So that is the solution to the equation. Thank you so much. See you in the next one, and bye-bye. And yeah, that's about it. This shows you problem solving. This shows you trial and error. And this just shows you general pattern recognition. So I think we're all about ready to start our advanced trigonometry unit very, very soon. Thank you very much. See you in the next one, and bye-bye.